Welcome to my channel. Today we are starting an agenda towards our 2023 BEC. We are going to solve math questions and prepare towards the BEC. This is how we've coded the questions. Now our agenda is agenda grade 1. That is, everybody who follows us must get a grade 1 in this year's math. Grade 1, agenda grade 1 in the 2023 math BC. This is an agenda, and this is how we are going to do it. The first question we are going to solve series of questions. This is our first question. We are calling it FMQ. That is first math question series. And like this, we will have episodes so that you don't get confused on the channel. I have episodes for you so that you don't get confused. Now, for you to get a question, you go to the website, which is www.mathclass.com. Then since you are in Form 3, when you get to the menu bar, you navigate to JHS3. You get to JHS3. Then you select Math. Once you select Mathematics, you will have your questions. Download the questions, then come and follow us here. That will solve everything. Make sure you have the question downloaded so I don't get confused. Let's get right into the questions. Now, before you can get grade 1 in math, there are certain things you need to know. Before one can get grade 1 in math, there are 4 most important things you are supposed to understand here. Now, the first one is your understanding of the topic. So we have understanding. You need to understand the topic. If you don't understand the topic, it becomes very difficult for you to pass. The next thing is your presentation. Your presentation of the work is very, very important. Once you understand what you are doing, it makes presentation of the work very easy. The next one is your accuracy. Accuracy. This has to do with your negative and positive. At times you know the thing you are doing well, but negative and positive disturbs you and you get wrong. And lastly, the last thing you need is time. You need to work within what? Time. There are instances where people complain that time given is not enough. I'm going to teach you here that the 2-hour paper is enough for you to write that. So these are the things we are going to combine here. So we are going to give you all these things here so that you get to understand how we do this. This is how we are going to start. So I hope by now you have downloaded the questions. Let's get into it right away. So we are starting our question. Let me go through this again. I said, for you to be able to get a grade 1, which is our agenda, a grade 1 in this upcoming BEC, rather, you need to make sure you understand. If you understand, we are going to make it clear here. Presentation of your work is very important because that is the only way you communicate with the examiner or the person who marks your work. Then accuracy, negative, positive, your integers can disturb you a lot. And you have to work within time. There are times people know, but the time is not enough for them. We are going to see how we manage all these. So let's get straight into it. If you have the question 1 is factorization. If you have the question 1 says we should factorize m plus n into bracket 2x minus y minus x into bracket m plus n. Now, before I solve this question, it's very important for you to know something here. WAEC has realized that most of you don't understand this. Hence, they always make sure they bring this kind of factorization. But let me show you one trick here. Now, in factorization, especially type 2 factorization, where you are giving something of, let's say, AC plus, so you are looking at factorization before we solve this, right? So let's look at this. Now, factorization. Let's focus on type 2. So we focus on the type 2. Now, in type 2, why can you do something like this? AC plus maybe BC minus, let's say we have I need CD, I need AD, so let me put A here, let me put D here, and put B here, and B there. Good. Let me say, why can you say something like this? In type 2, normally we have 4 terms, this, that, and that. If I'm to factorize this, what do? We group the first 2, and we see that, okay, the common term here as well is C. So we factorize C out, then we have A plus D. What I tell students that once you do this, don't think much. Just copy this and come and paste it here. So you copy this thing, paste it here as well, A plus B. With this, now B is the common one here and there, so you bring B out. Then, what do we multiply by this to get that, to get positive? So let's make this one positive so that it becomes an example. So I put positive here. Now, if you expand this, or before, if your final answer becomes what, you'll be told that take C and those outside the bracket, take them, put them into one bracket, and also maintain one of these. Now, this is the trick. This is what is happening. Now, once you get here, you can see that this guy and that guy are equal. So once you have this and this is equal, whatever is outside, you put them together. That's what is happening here. Whatever you have outside them is what you put together. It might be, normally we do just single letters, C and that. But when I can see that, what if they give us something like M plus N or M plus X, then A plus D, then minus, let's say B into bracket A plus B. When something of this sort is given, it is the same thing as this, just that they have made this one two terms. So you get confused. So this is the thing. Once you have such a question and you see two of these repeating themselves, the same thing, we are going back to, we maintain one of them and group those there outside. That's what we're doing. So let's apply that to solve our question one. In question one, you can see that what I explained here, that's the same thing we have here. We have M plus N, M plus N. That means they are what? Are the repeating ones. So I maintain it as well as M plus N. Then these ones are those outside. That's like I have C and B outside. Instead of writing C, they have given me 2x minus y. That's not my problem. My problem is that I can put those outside together. So this gives me what? This gives me 2x minus y minus x. Let me say that again. X, C is outside here, B is outside there. This and this repeated itself. This follows the same format. M plus N, M plus N. So when I put that together, it gives me this. I maintain one. Then those outside, like C and B, I also put them together. Now in algebra, once we see like terms, we can simplify. So this gives me M plus N into bracket as 1. Then this and this are like terms. So I can group them as 2x minus x minus y. Then from here, I have M plus N into bracket. This gives me x minus y. Finally, I have solved this. And this is why I can see that most of you cannot do it. So they keep repeating that. And that is how we solve question 1. Good. Now, question 1a. Let's go to question 1b. Question 1b. Question 1b. Now, in question 1b, it's an assets. A and B are subsets of the universal U. Now, this is a very easy question because they've already given the universal. But this one trick I'll show you here. In such questions, always, before you solve that question, always make sure you have the universal. And this is their trick. They'll always put the universal beneath the set. So if you don't, beneath the subset, which is A and B, if you don't read the question properly, and you start writing your set A, members of set A, you see that if set A was given as multiples of 3, and you don't know where to stop, you don't know the universal, you will keep listing down the multiples until you realize that, where am I going? Therefore, the trick here is that always when you are given this A and B, these two sets, will most of the time be what? Subsets of a universal. Always write down the members of the universal first, so that you know the range or you know your limit when you are listing these multiples. If you don't do that, there are times where students get confused. But if you look at this question, the universal set was even given very, very easy. They give us the universal set. So we just go straight into it and solve. Straight into this and solve. Straight into this and solve. So 1b says that A and B are subsets of the universal, and the universal was listed. So here we have the universal listed. Like I've said, in some questions, the universal will be at the bottom there. So let's list. We have members from 1 to 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this is my universal. Now, A and B are subset of the universal. And say A is such that A, we have what? Even numbers. So even numbers here, I have 2, 4, 6, you can say alongside me, 8, 10, 12, 14, 16, and what? 18. I say alongside me. You have to get yourself involved in the lesson. It's an engaging lesson, so get yourself involved. Then we have multiples of 3. Multiples of 3, I have 3. 3, 2 gives me 6. If you don't know that, you can be jumping 2 numbers. When I jump 2 numbers, I have 9, so I get it easily. When I jump 2 numbers, I have 12. When I jump 2 numbers, I have 15. Then that gives me what? 18. So these become what? These become the subsets of what? Of A. Subset of A. So we've answered it. Now list the members of the elements of the set A and B. Now the next question says, so we've listed the members of A and B. Now we need A intersection what? B. If we talk of intersection of a set, what that means is that some members of A can also be found in what? In B. If there's a member that is in A and also in B, we say A and B are what? Are intersected. And normally in the Venn diagram, this is how we represent them. The moment you have this, that means if we have A here and I have B here, they share a common member, and we call that intersection. They share what? A common member. A common member. Common means a member that can be found here, also be found here. If you are asked to list the members of A intersection B, what is A intersection B? We've explained intersection. Basically, members of A that can also be found in what? In set B. So let's go. Members of that. Help me look for them. So we have 6 is here, 6 there. So I put 6 here. Then I have 12 here, 12 there. So 12. Then we have 18. So these will be the what? The intersection of A and B. Then the easiest one, A union B. A union B. Now for A union B, that means we are combining A and B. A union B will not give you the universal. Why? We'll explain why A union B will not give you the universal. So let's combine this. Now in combining the two, you are finding the union of A and B. You combine the two sets, but if a number repeats itself in the set like an intersection, just maintain one of them and it should be in order. It can be in the ascending or descending order. So 2, 3, we have 4, there is 6, there is 6 here, there is 8 here, there is 8 here, we have 9, we have 10, we have 12, we have 14, we have 15, from 12 we have 15, we have 16, then we have 18. So this is A union what? Union B. A union B. Now, the last one, which is A union B complement. Let me just explain into details what a complement of a set is. Complement of a set. Now, if we say complement, in fact, complement means it adds up to something to complete it. That's the meaning of complement. Now, complement of a set are members of the universal that do not belong to a particular set. Members of the what? Of the universal that do not belong to a particular set under discussion. So let's use this as an example. If I want complement of A, which is written as A complement, then A complement are members of the universal. Again, A complement are members of the universal that cannot be found in what? In set A. So let's go into set A and see. What members are in the universal that cannot be found in set A? One of them when I look at is 1, 3 is in the universal, but you can't find it here. So it becomes A complement. That means when we add the members we are going to list here to A, it completes it to give us the universal. That's the meaning of complement. So we have 1, 2, we have 5. You can list it out alongside. Let's look for it together. I have 6, so 6 is a complement. 7 is a complement. I have 8, 9 is a complement. It's a complement. 10 is here. So 11. Then we have, look through with me. Get yourself involved. So we have this. There's 13. 13 is not here, so 13 is there. Then 15. Then 17. Let's be sure we have listed everything, so I don't make any mistakes here. That is our accuracy here we're talking about. Good. So this will give us the complement of what? Of A. When I add this one to that one, it gives me what? The universal. I can also go and find the complement of what? Of B. So the complement of a particular set, we say are members are members of the universal that cannot be found in a particular set. The set might be in a particular set. The set can be a subset of the universal. So that's what we've demonstrated here. Members of the universal that cannot be found in a particular set. Example, when we are dealing with what? Let me say a particular set. Example, we are dealing with set what? Set A. So if I ask you to do B complement, what are the members of B complement? Members of B complement will be members in the universal that cannot be found in what? In set B. So let's try and list them down. But before we do that, let's come back and do this. We have A union B complement. The question is to do A union B complement. In A union B complement, we are going to look for members in the universal, once again, members of the universal that do not belong to A union B. So we're going to look for set A union B and try to write out members here that are not here. That is how we've explained the complement of a set. If we meet this again in subsequent questions, we are going to explain it again. So don't worry. Good. So help me look for those members. Help me look for the members that are in the universal but cannot be found in A union B. Let's go. 1. I can see 1 here. So 1. Then there's 3 there, 3 there, 4. There's 5. 6 is here, 6 is there. So 6 cannot be a complement. 7 is a complement. 8 is not. 9 is not. 10 is not. 11 is. Why is 11 a complement? It's a complement because it's in the universal, but you can't find it in what? In the set A union B. Good. Then we have 12. 12 is here. 12 is there. 13. 13 will be a complement. Then 14 is not. So 17. So these become what? This becomes the complement of set what? Of set A union B. We've explained it there. So that's the meaning of what? Complement. Lastly, we have to illustrate the formation I in the Venn diagram. Anytime you are drawing a Venn diagram for this, make sure, because there's an intersection, you fill those with the intersection before you continue to any. I have seen students do weird things. I don't want to say them here, but I've seen students do many weird things when it comes to the Venn diagram. They feel, oh, set is so easy when they begin solving. So let's try and represent this on the Venn diagram. And when you are doing this in the exam, most of you would like to get a compass and now come and do all this. People who do that are those who don't understand. They're wasting time. Now, this is just a sketch. We don't need all those your fancy drawings. We just need a sketch. So just take your time, draw something nicely. Make sure there's enough space here. Before you put your rectangular box around this, don't draw the rectangular box before this. When you do this, you are forced to draw your circle very small into this. So don't do that. Draw your circles before you put this. Okay, let's go. So if this represents set A and that represents set B, then in what are the members of set A? But before we can do that, so let's go and write the intersection. So we have 6 here, we have 12 there, we have 18. Now let's go. Let's get into it. Straight into it. Now let's put the members of A. Members of A, we have 2, 4, 6 is already here. This circle represents A. 6 already here, so don't write 6. We have 8, we have 10, we have 12 already, we have 14, we have 16. So this becomes the members of, if you compare it here, you have to make the members. 2 here, 2 there, 4 there, 4 there, 6 here, 6 there, 8 here, 8 there, 10 here, 10 there, 12 here, 12 there, 14 here, 14 there, 16, 16, and 18, 18. I'm correct. Let's do that for this. Now let's do the members of B. So 3, 6, already here, so you don't do it. Don't do that. Then we have what? We have 9, 12 already showed up, then 15. We are done with A and B. Now let's see. Now here, this side will be those that belong to the universal but cannot be found in A union B. The complement will be here so that we can get the universal set. They are part of the set, but they don't belong to A, they don't belong to B, but they are part of the set. So let's put them there. So we just put them round 1, 2, It can be anywhere here. Found students where, because if I do this, most students would like to write it down here. No, just spread them across in the set. Once they are there, they are fine. They are fine. They are fine. Make sure you write them legibly so that the examiner can see and mark you correct. Good. So this is how we solve question 1A. Very, very well. Very, very simple. Very simple. If you have any question, you can give it to us in the comment section. And I'm going to answer you. I'm going to answer your question. Don't forget to share this with your friends. It's agenda grade 1 in what? In this year's BEC. We are going to make a grade 1. I promise you. When you follow all the steps we give you here, you are going to get your grade 1. Let's go to question 1C. Question 1C. Let me clean there. Question 1C. Question 1C. It's a vector question. Find the values of x and y in the vector equation. Find the values of, so 1C. Find the values of x and y in the vector equation. Now, in vector equations, here I can see three things applied here. I can see multiplication by a scalar. I can see addition and subtraction. I can also see equality of what? Of vectors in this. Three things are applied here. When it comes to vectors, one thing you should know is that vectors are not fractions. There are cases where students will put over a division sign here and they work with and they get wrong. So since there's not a division, there's no division sign here, then it means that 2 will not only multiply what? The x, but also multiply what? The y. That's one thing you should know. When it comes to math, the bracket means multiplication. Keep that. Bracket also means what? Multiplication. So 2 with this bracket means that 2 multiplies x and multiplies that. This is how we play it in what? In vectors. We call that a scalar vector. In scalar vector, or multiplication by scalar in vectors, if we have scalar, let's say I have a vector xy, I have a vector xy, and my scalar is k. If my scalar is k, if vector AB equals this, and k is my scalar, this is how I solve it. I'll say, okay, then k times vector AB means that I have k into bracket x or y. I just replace this with this. Equal to means that we are same. So if I don't want to write this, I can just replace this with what? With xy. Then this multiplies that. This is how we do scalar in vectors. K multiplies x, that gives me kx. That same k multiplies what? Y. That gives me ky. So this we are going to apply there. Ky sounds like a name, ky. You can take that as your ake, ky. Isn't that beautiful? Good. So let's apply that here. I'll maintain this. I'll have 5, 3 plus. Then I use the scalar here. Once it's outside the scalar. So 2 multiplies x. 2 also multiplies what? Y. So I have 2x, 2y. As I did here, I got kx and ky. Minus 1 minus 7 equals 0. Then I apply the addition of vectors. Let's look at that one here. If we are doing vectors and we are adding vectors, addition of vectors. If you are adding vectors, this is what you do. If I have vector A, x1, y1, and vector B, let's say, let me put addition and subtraction, I'll do both. Let's say I have vector B, x2, y2, and I have vector C, x3, y3. These are 3 vectors. And I'm to solve vector A minus B plus vector C. Then wherever I see A, I put vector x1, y1 minus vector x2, y2 plus vector x3, y3. I do this. Now, in addition and subtraction of vectors, we add and subtract corresponding values. Very important. We add and do what? And subtract corresponding values. Say corresponding values. Corresponding values. Good. We add and subtract. When I say corresponding, it means all those on top are corresponding. We also use this when we are doing angles. All those on top, I'm going to work them. And all those down, they are the corresponding values. So adding and subtracting corresponding values simply means that all those on top, put them together, those down there, put them, use the arithmetic to solve them. So based on this, we are going to apply that one here. We have 5 plus 2x. So I'm adding. What is happening? I'm using the integers here. Plus and minus. Minus what? 1. Then this gives me 3 plus 2y. Then we go back to integers. One of the most important topics in math is integers. This, I just explained that this bracket means multiply. So this negative will multiply this, and that gives me a positive what? 7. And this is equal to what? 0. This is equal to 0. Now, if this is equal to 0, now we apply what we call equality of vectors. I can equally write this as 0, 0. It's a 0 vector. A 0 vector is a vector whose components are what? Are 0. Then from here, we do what we call equality of vectors. What do we mean by equality of vectors? Because of this equal to sign, what that means is that the vector here, on the corresponding vectors are equal. Good. Because of the equal to sign, what it means is that the corresponding vectors are equal. I've explained what corresponding is. That those on top here are equal to this. And this one is also equal to what? That. In that case, for me to solve this, I'm going to get 5 plus 2x minus 1 equals 0 on one side, and the other side gives me 3 plus 2y plus 7 equals what? 0. I have this. Now let's solve for x. 5 minus 1 gives us 4 plus 2x equals 0. If your integers is weak, then you visit our video on integers. I'm going to explain it there so that you listen and get it strong. You need that in this your BEC integers. Very important topic in math. So this and this gives me what? Gives me 10 plus 2y equals 0. Let me finish one aspect and I come to this. Let me finish this. So this gives me 2x equals, when 4 is positive, it crosses the equal to sign, becomes what? Negative 4. This is what I'm talking about, your accuracy. Some of you will be in a rush and you cross without bringing the sign. Very important for you to note that. So this gives me 2x equals 2x divided by that, divided by what? That this will cancel this. So divide through by what? By negative 2. By 2. This cancels that. This goes into this minus 2. So I'll get x equals negative what? 2. X gives me negative 2. So I have x with negative 2. Then let's come to y. Y also gives me 2y equals minus what? 10. My y should be equal to minus 10. I'm dividing both sides by what? By 2. Or let 2 cross here. This is under change of subjects. It's very, very, very important. These are the topics: integers, algebra, then change of subject. These are the very key topics you need for you to get your maths right. So therefore, now we cancel this and we get y equals negative what? 5. Question says we should find what? The values of what? X and y in the vector equation. So therefore, our x equals negative 2, then y equals what? Minus 5. Down with question 1. Down with question 1. Let's go to question 2. Let's go to question 2. Question 2a. Very simple. But most people will get wrong. Let's see why. Now, find the sum of 2,483.65, comma, 701.532 and 102.7. Give me an answer in one decimal place. Now, in this case, don't worry yourself. It's just basic common addition. This is what I tell students. When you have this, make sure the points are aligned. Your job here is to make sure the points are aligned. Forget the numbers. How the numbers are aligned for your business. Your business is that make sure the points you are giving are in the same line. So I have this 6, 5. Then I put this point here. When I put this point here, I get 5, 3, 2, and that gives me 107. I don't care how the arrangement to be. The most important thing to me is that my points do align. Then this gives me that I have 7 here, I have 2, I have 0, I have 1. And I do this, then I add up. This will give me 2, so I have 2 here. Then this gives me 8. I have 8 there. That is this, and this will give me 11. 11 plus that will give me 18, so 8. Then I point, remainder 1. Then I add up this, I get 4, 6. So 6, that gives me 8. This gives me 8. 8 plus 4 gives me 12. So I put 2, remainder 1. Add 1 to this, I get what? 3. So this becomes my final answer. My final answer. But question says that I should leave my answer in one decimal place. Now, when it comes to decimal places, this is what you should know. Decimal places will start after the point. If I have a number, before we write the final answer, let's go through decimal places a little bit of number. Decimal place. Now, in decimal place, this is what you should know. If you have a number 4.217, after the decimal, the first number is your first decimal place. This is the second decimal place. This is the third decimal place. In fact, we call them the tens, the hundreds, and the thousand. After, normally we are supposed to be taught this in the place value chart, but when they end with this and they forget the decimals. But no problem. If you want a one decimal place, that means that after the decimal, you have to see only one word, only one number. That's what they want us to do here. One decimal place means I want to see only one number. That's what the examiner wants from us. After doing this, we got three decimal place, 1, 2, 3. But the examiner wants what? 1. And that's what you do. If you want one decimal place, what number do I have in the first decimal place? That number is 8. After getting that number, check what follows that number. What number follows my main number I'm looking for? I'm working with this guy, one decimal place. The number that follows, if the number that follows is 5 or more, add 1 to this. But if the number follows is 4 or less, maintain what you have. You get that? I'm saying that in writing decimal places, if I'm supposed to write this like this example, they are supposed to write this in 1 dp. This decimal place, not double punishment. 1 dp. Good. In 1 dp, I indicate a guy, the first person after the decimal is the first decimal place, and that's 1 dp. So I indicate this, or I look for this guy. After getting the guy I'm working with, I check who is there. The person here. If the person after my number is 5 or more, what we do is that we add 1 to this. But if not, 4 or less, we maintain it. We don't want any problem. Trying that with this, if I want to write this to 4.217 in 2 decimal places, then this is what I'm going to do. I'll look for the number in my second decimal place after the point. This is my first second. Then I check the guy after. It is what? 7. So this is 7. That means it qualifies here. So I'm going to add 1 to this. So this gives me 4.222. Good. That is in 2 decimal places. So let's apply that to 1 decimal place. So I'll write our final answer. In 1 dp, our answer equals, or we can just write our answer equals 3286 points. We check the number here. That is 8. So we add 1 to this. It gives me 9. So this in 1 decimal place. Final answer for this will be this. Very, very simple. Very, very simple. But if you don't take care, you might get wrong. And that's what they are looking for. We're going to start on question A. I like this question. It's about Pythagoras theorem. The question falls under Pythagoras theorem. Let's see how we can apply this theorem. Let me draw the diagram again. I beg my drawing there for take time. Okay, so we have this. Then we have that. But no, this is not drawn to scale. I beg. This is not drawn to scale. This one is not drawn to scale. Oh. Not drawn to scale. Oh. Good. So we have this. We have that. Now we have this here. After the question, I explain something small about Pythagoras theorem. Then we solve the question so that you can be able to follow when we are solving. So those of you who understand, don't worry. Yours is to listen and get understanding. Most of you always want to fight for marks. Get the understanding. That's very important. Understanding will help you solve this. Now, I have this one here. And I said this one falls under Pythagoras theorem. Falls under Pythagoras theorem. What is this theorem about? This thing should be straight. Straighten it for me, huh? What does this one? The Pythagoras theorem deals with right angle triangles. When we say a right angle triangle, a triangle with 90 degrees is a right angle triangle. Now, what did Pythagoras say? Pythagoras said that, okay, or he brought the theorem, he was saying that, okay, in any right angle triangle, the longest side, or the side that is pointing or facing the 90 degree, he wants to call it the hypotenuse. That's what he wants to call it, hypotenuse. then depending on the angle of which you don't mind doing GSSA, but depending on an angle that was placed here, this can either be an opposite or adjacent. So I like to put it in, I don't want to bring the angle, so I put the opposite here, but get to know that doesn't mean that you always put opposite here. Opposite will always face the angle under discussion. What angle are we looking at? If you are looking at an angle theta, then opposite will face or the angle. But here in GSS, we don't want to do so. Let's just put them anywhere and we are fine because it still help us to work. Then the last side becomes what? Adjacent. So this is what Pythagoras said. He labeled this. His theorem mostly or works with what? A right angle triangle. If the triangle is not right angle triangle, the theorem does not work. We go to a higher rule, which is either the sine or the cosine rule. That's for those in essence. But those of us here, let's limit ourselves to this. Now the theorem says that the hypotenuse squared equals the opposite squared plus the what? Adjacent squared. This is a theorem. This Pythagoras what? Theorem. This is what Pythagoras said. He studied triangles and he said that once you have this, then the hypotenuse squared equals what? Equals the opposite square plus adjacent square. And addition is commutative, so you can say adjacent square plus that. It's not fixed. Let's put that, it's not fixed that you should always write this. No. Good. Now with this understanding, let's see how we can play this. The question says that in 2b, in the quadrilateral ABCD above, AB is 3, the length AB is what? Is 3 centimeters. And that's one thing I tell students, that when it comes to math, our power, those of us who do math, our power lies in the what? The use of symbols. We use symbols to say a lot of things. So we don't talk much in math, we just shorten things using symbol. I'll give an example of what I mean by that. Good. So if you see this and write AB, AB with this means that the length AB or the magnitude AB is a symbol. Instead of writing the length of AB, an English man will write that. We don't want that. We just write this and it means the length of AB. If I write this same AB and I put this on, it is no longer the length. It becomes a vector. And this bars here means that the length of that what? Vector. That tells you how powerful math can be. Good. That is that by the way. But very important. Good. Let's go. So now, we want to apply this theorem to solve this question. They say in the quadrilateral, they say the angle is 90. We can even see that. And one thing you should know, the moment you see a 90 degree, that tells you that this line here is the height. Always keep that in memory. Always keep that in memory. That the height or the height of any diagram will always make an angle of what? 90 degree with the base. If it's not making an angle of 90 degree, that is not your height. The two lines, the height and the base, are said to be perpendicular. They are said to be what? Perpendicular. So take note that any line that makes an angle of 90 degree with the base becomes my height. Okay, let's go. So we are going to solve this very, very well for you to know based on what we have written here. I hope you've copied this and write it somewhere for reference sake. So this is what Pythagoras said. You can do so many with this theorem. Okay, now we have to find the perimeter of ABCD. Perimeter. And when we say perimeter, what is perimeter of a figure? Perimeter basically means that the total distance around the figure. When we say total distance around the figure, that means that when we should add all the sides. So perimeter here becomes the side AB plus the side BC plus the side CD plus the side what? DA. This is the perimeter. I'm going through again. I said perimeter means we are adding the total distance. So this is what I tell you. Normally, pretend or imagine you are walking around this thing. If you are walking around, you move from here to there, from here to there, from there to there, from there to there. You are walking around. The moment you do that, you have gone around the perimeter of this. Now we are adding the side. If you look at this clearly, we have AB, we have this, we have that, or we don't have this. That means we have to find a way of getting AB. And that's what we are going to do. And that's why we need to apply the Pythagoras theorem. Now, in applying the Pythagoras theorem, I want to go a little bit fast. So let me just skip some of these things and go very fast. I'll come explain them again. I'll explain them, don't forget. So I'll consider this triangle, which is triangle ABC. What am I doing? When I consider that, I'll use Pythagoras theorem to get its hypotenuse. When I get this guy's hypotenuse, the hypotenuse will now serve as a base for triangle ACD. It is serving as a base now. Once it serves as a base, I have this with that. I can get this guy again using Pythagoras. So I'm going to divide the shape here into two right angle triangles. Then I'm going to use that to solve the question. So let me first of all start. So find the perimeter. I'll come to the perimeter. I can say the perimeter should be equal to AB plus the length of BC plus what length again? CB plus BA. I can say this, yeah. But if I look at this, I have all this length. I have AB3, I have BC, I have CB, but I don't have AD. So how do I get AD? This is what we are going to do. We'll consider triangle. We'll take triangle. So taking triangle ABC. If we take triangle ABC, once we do this, the person marking his attention goes to that. Say, take you write this. It's the way of presenting work. Very fast. If you understand, it will not take your time. If you understand, it will take your time. And if you understand this, you just go straight away. So taking this, we can say that from who? From Pythagoras. This time, don't go and quote hypotenuse squared because no. We know that AC is the hypotenuse, so you go straight away and tell them that from Pythagoras theorem, AC squared, we know is hypotenuse, equals 4 squared plus 3 squared. We understand this. Don't go and quote. This is some of the things that will take your time. Don't go opposites. No, this is what the theorem is saying. That AC, the person looks at this AC, that is correct. Now let's go. So this gives me 4 squared is what? It's 16 plus 3 squared, which is 9. This gives me AC squared equals that. So I sum this. No one, they are like terms. Why they like terms? They are constant terms. They don't have variable. So we can add them together. And this gives some 25 here. And I get AC squared equals 25. And I want to find AC. Change of subject. If you have a square and you want to make this the subject, all you do is what? To square root. So we square root both sides. Square rooting both sides, I'll get what? I'll get AC, the length AC equals the square root of what? 25. 25 is a perfect number. We'll look at it. So let's put the square here. This square cancels the square root. They're gone. So therefore, now AC, some people say it's air conditioned. AC will be equal to what? Equal to root of 25. Now, what number do you multiply by itself to get 25? That's why we say a perfect number. What are perfect numbers? A number that multiplies, or the answer we get from multiplying a number by itself. That one is a perfect number. So perfect numbers are numbers we get from by multiplying a number with itself. A perfect number is a number we will get by multiplying a number with itself. So what number do we multiply to get this? And if you don't know, then you have to go and learn the first 15 perfect numbers. You have to go and learn them, the first 15 perfect numbers. So it is 5 times 5 that gives me this. When 5 multiplies itself, what do I mean by that? I say a perfect number is a number times itself. When 1 multiplies itself, 1 gives me 1. When 2 multiplies itself, 2 gives me what? 4. When 3 multiplies itself, it gives me 9. When 4 multiplies itself, it gives me what? It gives me 16. 5 multiplies itself to give me 25. And continue to the 15th one. You should know these ones are referred to as the perfect number. So when you're working, you see them straight away. If you don't practice them, you don't get it. It's very simple. Math is about practice. You need to practice well. Good. So like I said, from here, that means the length AC equals what? 5 cm. Don't forget your unit. 5 cm. Very important. So now we have AC. After taking that triangle, still on this. Now let's go. Now let's take triangle, taking triangle. This time we are taking triangle what? A, C, D. Good. Taking this triangle ACD. Now, once again, now we know this side of the triangle to be what? To be 5. And like I said earlier, it has become the base. So if I hold this guy and put it down so that it sits down, then 5 becomes my what? My base, and this side is facing the 90. So we say once again that from Pythagoras, what do we have? This now becomes our hypotenuse. So we'll have AD squared, the length AD squared, equals the length this squared plus the length AC wall squared, AC squared. So straight away, what do I have? I have AD squared equals BC is 12 squared plus 5 squared. I have this. Now, in this case, let's go very fast. This will give me 144. 12 times 12 is 144 plus 20 what? 25 equals AD squared. Good. Now, here we'll have this will give me 169 AD what? Squared. So, like I said, if you want to get rid of the square, what do? We square root. This is square root or the radical sign. Put a radical sign here. I forgot I said, no problem. This will cancel this. We'll have what? We'll have AD equals root of what? Root of 169. If you've gone to the perfect numbers, you realize that when you multiply 13 by 13, you get this. 14 by 14 gives you 196. Good. So this will give me AD equals 13 cm. Now the AD I have here. So now I'm going to now do my perimeter. All these things you have to, if you work fast, this is very, very easy. I'm just taking my time because we are looking at what? At a process to making a grade 1. So I'm not rushing you here. No, not at all. Taking time to do this. Good. So this gives me what? This gives me my perimeter. My perimeter now becomes, now we have AD to be 13 plus DC. DC is 12 plus CB is 4, then plus 3. Then we add all this. This and this will give me 25. So 25 plus 7. That will give me some 32, right? So plus 7. 7 that will give me 12. So 2. So 3. So 32 cm. So this becomes my perimeter. So we are done with that one. And perimeter. Then the last question, 2bii. The last question. And we pause the episode here. Continue the second episode with question 3 and 4 of this first math question. Now we have to find the area of, we are finding the area of ABCD. Area of the figure ABCD. Now for the area, what we have to do is we find the individual areas and add them together. Very simple. I'll find the area of this triangle, area of that triangle, then I add it together, then I get my what? I get my area for the figure. Unlike perimeter, where for perimeter we have to go round and take the distances. But for this, yeah. So let's take, once again, let's take what? Taking which one? Taking triangle ABC. If you take that triangle, what will be the area? And I said something earlier on, very important to me, that the height always makes an angle of what? 90 degrees to the base. So if I take this triangle, my base will be 3, then my height will be what? My height will be 4. So area of triangle, Triangle ABC equals half times the base times the height. Now what's our height? Now if I explain that, so we have 1/2. What's our base? Our base is 3 times the height becomes what? 4. Yes, it is one very, very important point. Now in this case, we can cancel 2, can cancel 4 to give me 2. Very, very important. But if you have this times into bracket 3 plus 4, as in solving of maybe the trapezium times height. Let me take this one even out. Now you can cancel this with this. It's not possible. You only cancel when they are multiplied. Take note of that. I've seen students do it severally. And I always tell them, don't do this. If you want to get your grade 1, you also listen to what? Instructions from your teachers. Very important. Very, very, very important. So we have 3 times 2, and that gives me what? That gives me this area. So it gives me 6 centimeters squared. Very, very important. Units. I always say that numbers don't make sense on their own. They don't make sense unless those talking or those describing, they know what they are talking about. If not, that numbers don't make sense. If I say, okay, 6. You look at it and say, look at this man, oh, 6. What is 6? You want something to go with 6. That thing that gives the number its meaning is what we call units. So if I write 6 and I don't put any unit, it doesn't make sense. It might mean anything. It might mean 6 goats. I like to use goats a lot. Okay, now let's go move on to find the area of, okay, let's take triangle so everything becomes nice. This time let's take, so taking triangle, I want to use the same thing. Okay, ACD, taking triangle ACD, the area of triangle ACD equals, area of triangle ACD will be equal to, once again, how times the base times the what? The height. How base times height, which gives me 1/2. What is the base here? Once again, explain. The base here will be 5, and since this one is making an angle, forget the shape of the diagram. No, what I have said, and one thing you should take note in math is that normally you listen to what we say more than the diagrams, because what we say is what we use for the diagram. I might well have said this, but the diagram will look different. All that you look for is the principle. What did I say? I said that the line that makes an angle of 90 degrees the height. That's what you need. So the fact that they've turned the thing, or the thing is tilted, doesn't mean that that's not the height. The height should not always be straight in the diagram. Is the line making an angle of 90 degrees the base? That is your height, brother. That is your what? Your height. So this gives me times the base, which is 5, and the height, which is what? Which is 12. So from here we can cancel this, cancel this. This will go here 6 times. Then I have 5 by 6. 5, 6 is what? It's 30. So 30 centimeters squared. I'll go and find the area of the figure. So the area of this, area of the figure, let me put it here. Area of ABCD will be equal to area of this plus area of that. That is 6 plus 30. And that gives us 36 cm squared. Good. So we've been able to exhaust question 1 and question 2 for this episode. We shall continue with question 3 and 4 in the next episode, 5 and 6 in the other one. Then we are done. Look at the section A's. We are done. If you have any question, you comment, and we are going to answer you in our next video. We are going to answer you. So just make sure you go through what we have said. Play this, listen to it. And this advantage, you can pause, go back, check something, come and look at it. Don't get anything, just look at it very, very well. And we shall meet again. Don't forget, tell people, subscribe to the channel. You should like and share. Thank you very, very much for joining these lessons.